Okay, let's go ahead and start writing our code. Up here in the black hole fragment shader, I'm going to just type return 1.0 and space down a little bit, because this is ultimately going to return this value, but we're going to make it so it returns other values as well. And we'll get to that in just a bit. First, I'm going to come into the black hole USF here and get rid of this function because we don't need it anymore. And I'm going to make the function that's going to be doing all the work for us here. It's going to be the black hole function. So I'm going to type void because this function isn't going to return a value per se. It's going to take in inputs and then modify those inputs and then output those. So usually when a function is supposed to return a single value, like a float, we would type float before the function call. And that tells the compiler that this function will return whatever this type actually is. But when we type void, it's not expecting to return anything. So we can kind of just call the function, give it its inputs, and then those will get changed within the function, and then it can output those. And that's what we're going to do. So I'm going to say void black hole. And here's where I'm going to declare the inputs to function. So I'm going to type in out, which says that I can make a variable, input it into this slot, and then I can change that variable, the value of that variable in the function, and then it will kind of like inherit those changes. So I could say in out float for color, because the function will need to actually return a color. And I'm going to have another in out variable, and this is going to be a float 3. And I'm going to call this dir for direction. And I'm going to say float 3 camera position. Now I don't have an in and out here for the camera position because I'm not going to be changing the camera position and expecting to do something with it. This is just a required input here. I'm going to hit space and do some curly brackets and enclose that, and that's going to be our function. It's just empty right now. It doesn't really do anything. But if you're new to coding in HLSL, I can kind of show you what this function looks like as a material function inside the editor if we were to make that as a material function. So I'm going to come in the editor here, and I've kind of already prepared this, but I've got an empty black hole function here, and I've got 3 inputs. I've got a color, a vector 3 called direction, and a vector 3 called camera position. And notice how the color is just going straight to an output called color, and dir is going straight to an output called dir. And that's kind of what this is doing. So I could come in here and modify color all I want to. I can tell it to return a value, or I can tell it to just, be red or something like that, or multiply it, or, add to it, all this stuff. I could just say float 4, add to this red or something like that, and compile this. And if we go back to the black hole shader and I drag this function out, that's kind of like what the inputs are going to look like. So if I make some parameter called color, and I just set it to black and I plug it in, and the output will be red, and it's giving me an error because it's expecting me to have these other inputs, just like it will in the code. So I have to make these inputs. I can make a vector 3 for direction, and another one for camera position. And it's spitting out this error because I'm using the white pin at the top of this float 4 node here when I actually need to append the alpha here to make it a float 4 and plug in here. Yeah, so now that works. So this is just kind of like a demonstration of kind of what's going on in our code right now. So I'm going to just delete all this and plug black hole back in here, close out of here. Yeah, we'll save the changes. And let's go back to write some more code here. The function is actually pretty much doing exactly what I want it to do right now for this first part. So now I'm going to focus on the actual code that's going to be plugged into the black hole node right here. I'm going to bring out two properties now, the camera position and the camera vector. And I'm doing this in code because I want to keep as few parameters as possible going into this custom node that we're going to add. And it's going to get pretty cluttered later on. There's probably going to be like 20 pins or so going all the way down here. So I'm going to, instead of adding camera position and camera vector here and plugging those into the custom node, I'm just going to do it directly in code. And to do that, I'm just going to type float3. We're going to get the camera position, and I'm going to add WS for world space. And that's going to be equal to resolved view, which is a struct that's populated in C++ full of uniform values. So like matrices, camera values, and other things that are uniform values across the entire screen is going to be in this resolved view struct. And the value we're looking for is called translated world camera origin. And it's translated because it's converted from large world coordinates to just a regular float3. So if you're trying to follow this tutorial in Unreal 4, this code's not going to work for you, just a heads up. So the next we're going to do is camera vector world space. And this is going to be the vector that points away from the camera into the scene. And this is going to be set to the negative parameters dot camera vector. It's negative because it's pointing away from the camera. Or if you left this negative out of here, it would be a vector pointing back inwards towards the camera. So I've got these two values, and I'm down here, I'm going to make a float4 called color, and I'm going to set this equal to, well, I'll just set it equal to 0. And this syntax will set all the components of the float4 to 0. So I've got everything I need to plug into our function that we created here. Color, a direction, and a camera position. So I'm just going to say, just call black hole, and I don't have to set this equal to anything because it's void and it's not going to return anything. So I can just straight up just call it right here. And I'm going to say color. And which one did I do first? Direction, right? So say camera vector world space and camera position world space. We'll add a semicolon there. All right, and let's just go ahead and Control A and copy this and make sure we save this with Control S. Let's come into material editor over here and let's keep our fingers crossed and paste this in. And let's see if it works. All right, so far it's looking pretty good. We have it returning 1. We didn't get any errors, which means that the code works. But I want to extract the camera vector here to start setting up what we're going to do. So I need to output those values. So I'm going to go in my custom node. I'm going to come down to additional outputs, and I'm going to add 2 of them. One for color and one for direction. Now, I bet when we add this color here, it's going to spit out an error. Yeah, see, it's saying a redefinition of formal parameter color. And set this to float4, and I'm going to call this one just dir. I'm going to set this to float 3, like so. So let's address these. This redefinition of a formal parameter means that in the code here, in our fragment shared, and this is the code that gets pasted back into the custom node, we have a variable out here called color. The material editor has kind of like set that up, so it's expecting, this is already defined pretty much. So here we're redefining color, which is a no-no for the material compiler. So let's back out that float for, since this is technically already now, because we've named it here and we've set it up on the node, it's already defined a float for called color in the material code that's invisible to us. So we've got this color here, and we also need to make a variable called dir. And I'm gonna set that equal to camera vector world space, just like this. And then I'm gonna switch this out with dir. So now if I save this and copy paste, this should work. Yeah. So now it's working, and remember, we're just returning a value of 1 in our code right here. So that's what the value of this return is, but we want to see what the direction is. So I'm going to plug in direction into emissive color, and I should be getting the resulting camera vector. So now that I have this camera direction, I can go ahead and set up a little, I could use the camera direction to sample a cube map. So I've got some textures that I've preloaded with the project that we're going to be using. And the one I'm going to be using at the start is this texture called grid. And this is going to help us debug and also see some things. So I'm going to throw this texture sample in here, and I'm going to plug dir directly into it. Just make sure, yeah, okay, dir into UVs, and we'll plug this into emissive. And I'm going to set shading model to unlit here. And I'm going to turn off auto exposure here and just set that EV range to 0, that EV 100 to 0. And now when I come in here and I look around, remember this is an inverted sphere. I can kind of come all the way in here, look around, and I see this grid. And this is going to help us when we start implementing the gravitational lensing. Let's go ahead and start setting up our RayMarching code that is going to render the actual black hole in the center of the screen. And to help visualize what exactly is going to happen, I've gone ahead and set up a little Photoshop diagram for us here to look at. So this gray area is our inverted sphere that our camera is inside of, and we want to render a black hole right here, which for the time being is just going to be represented as a black sphere. So we have our camera position, and we have our camera vector. So what we need to do is step along the camera vector, and every time we take a step, we need to check to see if we are inside of this sphere. So what's going to happen is we're going to say camera position plus the camera vector will give us a step size of 1, because the camera vector is normalized and its magnitude is 1. So camera position plus camera vector results in a step that's 1 unit length long. And when we step, we're going to just check to see if we're inside of this sphere. So we're going to do this many, many times to see if we intersected the sphere or not. And if we didn't, it'll keep stepping all the way until the end of however many steps we choose. And if it didn't intersect the sphere, it's just going to return the camera vector pointing along this direction. So nothing would have really changed at all. But if it did intersect the sphere, we're going to create a new value for called a mask value, and we're going to set that equal to 0. It'll default to 1.0, but we'll set it to 0 if it's inside the sphere. So we'll be able to kind of like use that mask to visualize our black hole. So it's kind of like an overview of a visual overview of what we're about to do. So let's get out of Photoshop and pop back into our code here. And we'll pop into our black hole shader, and things are going to get a little involved now. So we need a couple of things in order to kind of do what we just illustrated. The first thing that I want to put in here is an actual structure object to contain all of the properties that we're going to need to render the black hole. And we're going to grow this list as we move forward in the training series. So I'm going to say struct black hole properties. And I'm going to have curly brackets here, and I'm going to have a semicolon at the end of it because we're defining an object here. And a struct is just kind of like a container that can hold a lot of values so that I can just pass the struct into the function rather than like a bunch of values as inputs. So I'm going to have two values here. I'm going to call it float mass, and this is going to be the mass of the black hole. And I did 2 forward slashes there because that is going to create a code comment. And it's just helpful to have these comments in here to remind you of what you're doing. And then I'm going to have float event horizon. And this is going to be the event horizon radius, or I guess we can just say like the black hole radius. And this is usually just set to whatever mass is times 2. And that is a physics thing. So we can get into that a little bit later. And I would, you could probably think like, well, what about like the position of a black hole? So the way that we're going to build this is we're just going to always assume that the black hole is at the origin of the world. And later, we can do some tricks to, instead of having the black hole at the origin of the world, we can just have the black hole be at the origin of the inverted sphere mesh, no matter where we move it in the world. And that's, we'll transform all this stuff into local space a little bit later, which is really easy to do, but let's not worry about that for now. But I do want to comment and just say, position of black hole is assumed to be at the origin. Okay, so we have black hole properties, and to round this all out, we'll go back to our fragment here, and we're actually going to make a black hole property struct. So just because it's declared and like defined here doesn't mean we've actually made the object. So back in our black hole fragment shader, I'm going to say black hole properties. And that's the type. So that's kind of like saying like float, mass or whatever. It's black hole properties is the type. And I'm just going to shorten this to BHP. And I'm going to hit semicolon. So we've created the object and it's called BHP. And now I'm going to start setting the properties here. So I'm going to say BHP.mass equals mass. Now I haven't declared or I haven't defined the mass value in code. I'm actually going to do that back here on our custom node. I'll do that just a little bit later, but keep in mind that this mass value is going to be added as an input pin here, and then we can add a parameter that plugs right in so we could modify it later. And I'm also going to say BHP.event horizon. I'm just going to set this to mass times 2, like so. All right, so now I'm going to come back to my black hole shader, and now we have to add that mask property that I was talking about. So we're going to add a new in-out argument here. I'm going to call this float mask. And at the end here, I'm going to add a black hole properties argument. And I'm going to set that value equal to BHP. Now, anything that I do inside my function, if I need to access a member of my black hole properties, which will grow quite substantially over the course of the series, I just have to type BHP and then access the variable. And that keeps my function argument list really clean and doesn't get out of control. Okay, so the last thing we're going to need before we implement the basic RayMarch code is a function that's going to tell us whether or not we crossed the event horizon, or in other words, it's just going to check to see, like back in Photoshop here, it's just going to check to see if we are inside the sphere. Now, if this sphere is in the origin, or it's centered at the origin, all we really need to do is get the length of the current position. So as we step along the ray, we're updating the ray position every time. We're moving it forward along that vector. So we can just get the length of that position. And the length is going to essentially just be the distance to the origin. And if that distance is less than the event horizon radius, we know that we're inside the sphere. So let's go ahead and make ourselves a function that tests to see if we're inside a sphere or not. So I'm gonna go ahead and make a new function, and it's going to return a Boolean or just a value for true or false. I'm going to call the function crossed event horizon, like this. And it's going to take two arguments, float 3, we'll call this ray position, and I'm going to pass in the black hole parameters struct, and we'll just call that BHP. And what we want to do here is, if the length of our ray position, and this length function is just an HLSL function that'll take a vector and essentially return its magnitude, but since ray position is a world position, asking for the length of ray position is just going to give us the distance from the origin to that actual position. So this is a really good value to test to see if we're inside of a sphere or not. So all we have to do is say, hey, if the length of the ray position is less than equal to our black hole properties event horizon value, we know that we're inside that black hole. So we can just say return true. And if this doesn't happen, we'll just say return false. All right, so now we should have everything that we need to start writing our RayMarcher. So down here in our black hole function, I'm going to initialize two variables, and these are going to represent the initial values of our ray that we're going to be marching along. So I'm going to say float ray position is equal to our camera position, and that needs to be a float 3 actually. And ray direction is going to be equal to dir, which is always coming into this function as the camera vector. And then I'm going to comment in here, begin RayMarch. This is going to be our loop here. So I'm going to make a for loop. So I'm just going to say for, and then the syntax to make a loop work here is I'm going to have to give it an integer and call that variable I. I'm going to set that to equal 0. So a for loop, what it does is it'll execute code, and it will do that for essentially a number of steps. So it'll go through this code, and it will execute for every step that there is, and after that code has been executed, it will increment this I value. So it's going to start at 0, it'll execute the code that's in the for loop, and then it will increment the value by 1, and it's going to do this while I is less than the number of steps that we want. So up here, I want to define, I'm going to use a hashtag here. So I'm going to say define steps, and I'm just going to set that equal to 250. And there's no equal sign needed when you're doing a define like this. And this is just saying that we can access this steps value in any function that we have in this shader file, which is kind of useful. It's sort of like a global variable. So I'm saying for int I equals 0, and then there's a semicolon. I is less than steps, then another semicolon, and then I plus plus. And then the for loop will be contained inside these curly brackets right here. So then all we want to do is say, if we crossed event horizon, that's our function up here that we're calling, and we're going to take the array position as our position that we want to check, and we'll just pass in the black hole parameters, which is coming into the black hole function through this up here. If we cross the event horizon, we're going to set mask equal to 0, and then we're going to break out of the loop altogether. So this will cease the execution of the loop, and it will just go to whatever line of code is down here. But if we didn't cross the event horizon, it will not run any of this code, and we'll jump to this cursor, or this line down here, where we'll just increment our line. So we'll say the ray position plus equals ray direction. And this is just saying that I'm adding the ray direction value to the ray position. So if we bring it Photoshop here, this is what the for loop is doing. We're starting at camera position. We're setting that equal to ray position. And then if we didn't cross the event horizon, we are adding the camera vector to this position. So it's going to step forward like this. Every time we step, we're going to test. If it fails, step again, test. And we're going to keep doing that until we either detect that we're in the event horizon or until we ran out of steps. And that should be all that we need for this to work. So I'm going to go ahead and Control S, and then we're going to come back into the fragment shader, and we need to update this to include the mask value. So I'm just going to say mask equals 1.0, and then we'll add the mask here because it's our second argument. And our black hole properties struct is going to be in this argument. So let's copy this, and we'll come back into Unreal here. And let's go ahead and paste this in, and we're going to get some errors here really quick. So it's telling us that in our black hole shader at line 10, there's an unrecognized identifier called black hole parameters. So if we pop back in here, we can check and see what's actually going on. So I called this parameters instead of properties. So I'll fix that little error. And let's come back into Unreal, and you can kind of refresh this by clicking on the custom value and clicking in white space here. And if you hit space, you can just hit enter again. All right, so now we're getting the errors I'm actually expecting. We need to add a mask value for an output. So we'll just say mask. I'll leave that as a float 1. Whoops, I don't want to capitalize that A. All right, and it's also saying there's an undeclared identifier for mass. Now, if you remember, we did black hole properties.mass is equal to mass. So we actually need to add this as an input to our custom function over here. So let's go ahead and we already have an input here. So I'm just going to rename this to mass like this. And let's just add a scalar parameter called mass and plug it in. All right, everything compiled. Now we can keep our fingers crossed and preview this value of mask here. It should be all whites except for a small black area in the middle. And of course, we're not getting that. We're just getting a value of black, which is telling me here that something is probably wrong with either our function or our camera position input, because we set our value for mask equal to 1 at the beginning, and the only time we change it is if we cross the event horizon. So this is really simple logic. I don't think that's wrong. So it's probably our camera position here. And I think I see what I did wrong here. Since Unreal Engine changed to 5, there's kind of some weirdness with how it uses large world coordinates. And those are like the really high precision world position coordinates. And you have to do some extra work in HLSL to kind of get the right value out of that. So we have to make a really small change here. We're gonna remove this translated here, and we're just gonna set it equal to the world camera origin. And we'll copy this into our code here and hit enter. Now it's saying that it can't convert from a large world coordinate vector 3 to a float 3. So what we have to do is use this function called large world coordinate to float, and we have to encapsulate this. Because this resolved view world camera origin is a large world coordinate vector 3. So this function should convert it to just a regular float 3. So let's copy this really quick and we'll paste it in. Okay, we're getting our white value back. Our mass is currently set to 0, so let's set this to something like 10 and zoom the camera in. And there it is. You've got our black hole right in the middle there. And if we zoom too far out, it goes away because we're leaving the steps. Like our steps are ending before it even hits that black hole. So our camera kind of has to be a little bit up close to it like this. Like reduce the size of it like this, and yeah, we have a sphere in the middle here. So now that we have this mask, I can just multiply this by, let me hide this here. I can multiply our mask by our cube map value here, and we'll plug this into emissive color. And now we have the beginnings of our black hole.